Okay, mic on.
Okay, so hi everyone, thank you so much for coming. I'm delighted to introduce Dr. Barry Atkinson, who is the lead environmental virologist at UKHSA and is an expert on many things, but he agreed to talk to us today about monkeypox, but he has a specific interest in high consequence infectious diseases, so he's just a great collaborator in our group and hopefully with the wider field in the school as well. So yeah, after this session there'll be a Q&A, and I kept Barry's diary quite empty in the afternoon, so if anyone wants to have a chat with him, just let me know. Thanks, Barry.
Cool, thank you very much, Rachel. Okay, so we're going to be talking about monkeypox today, and in particular its rise from obscurity to notoriety. Now, the story of monkeypox begins back in 1958 when a colony of laboratory monkeys was imported into Denmark, and this importation was from what we now know to be the endemic regions of Africa. And the scientists noticed that there were these unusual lesions on these monkeys, and after investigation they worked out that this was a double-stranded DNA virus, which was different from any other pox virus that had been seen before. So unsurprisingly, they coined this new virus, monkeypox virus. And it'd been another 12 years before we realized that this virus was capable of causing human disease. And this was due to studies in pox disease in children in the DRC. And it was found that much to their surprise, that the virus causing this was not smallpox, which is what people were expecting, it was actually monkeypox virus. Now, since the 1970s, there hasn't actually been a huge amount of research on this virus or this disease. It very much falls under the umbrella of a neglected tropical disease. But what we do know from this research was that there were at least 2 classical clades. And these were originally known as Congo Basin and West African clades. And if you've been keeping up with the latest news on monkeypox, you might have seen that in the last few days that these have now been renamed. This is going to be Clade 1 instead of Congo Basin, and Clade 2 instead of West Africa. And indeed, the West African clade is going to get further subdivided. So 2A will be what we used to know as West African. And then this monkeypox virus strain that's now circulating, causing this outbreak in 2022, this is slightly different from the original West African clade. So this is going to be 2B. But even with the early research, it did appear as if there was a distinct difference in the case fatality rate between Congo Basin and West African clades, just over 10% for Congo Basin and around about 3.5% for West African. And when we look at what's happening with this current outbreak clade, it's significantly below 0.05%. And this raises the interesting question of, is what we're seeing here in terms of these phenotypic differences in the case fatality rate, is this due to the genotypic differences, or is there something else that can explain this? Things such as differences in healthcare or socio-economic conditions between the places that people with monkeypox virus are becoming sick. And we still haven't got to the bottom of that question yet. It will be an interesting one to watch going forwards. What we do know from the early research is this is very clearly a zoonotic virus. It has a natural small mammal reservoir. We haven't pinned down exactly which animals are responsible. There's a lot of evidence to suggest that squirrels and other types of rodents can naturally harbour this virus. And human cases occur when there's interaction with these infected reservoir mammals. And the majority of the human cases that we saw before the start of this current outbreak were primary cases of monkeypox. This is zoonotic spillover. In particular, out in endemic regions, money can be made by children going out and trapping these mammals and then selling them in local markets. There were secondary transmission cases, and these were most likely due to direct or prolonged close contact. So this brings into the possibility respiratory transmission or fomite transmission. But because we've seen so few secondary cases in these endemic regions, it's unlikely that these are major contributors to overall transmission. In terms of the number of cases that we saw prior to this outbreak, there was a really nice review published early this year which summarised all of the confirmed human monkeypox virus cases, and they broke these down by decade. And what you can see is in the 1970s, there were some sporadic cases in West Africa, and then a few dozen cases in the DRC. When we moved into the 80s, it's a pretty similar picture, sporadic cases in West Africa, but now we have more than 300 cases reported in DRC. Into the 90s, similar again, we're now up to 500 cases in DRC and just a handful of cases in Gabon. But it's when we moved into the start of the new millennium, this is where we saw our first big change. And in fact, there's two things to note here. Unfortunately, only one of them generated headlines, and that was the 47 cases that were reported in the United States. Now, these cases occurred due to the importation of giant Gambian rats into the US to be used to be sold in pet stores. And unfortunately, some of this imported rats were infected with monkeypox virus. What was even worse is they were imported at the same time as prairie dogs, which are very popular pets in America, and these are highly susceptible to monkeypox. And so, unfortunately, these infected animals are sold in many pet stores, and at least 47 cases occurred. What didn't generate any headlines was the fact that we saw a 20-fold increase in cases in the DRC. We're now up to more than 10,000 cases. And when we look for the last decade that we've got full data, and we see a very similar picture. Again, we've got these events that generated a large number of headlines. We've got importations into the UK, Israel, and even Singapore. These generated headlines. What didn't was a further doubling of cases in the DRC. We're up to now nearly 20,000 cases, and also 181 cases in Nigeria. Now, this is a country that hadn't reported a human case of monkeypox since the 1970s. This is where our attention should have been focused, not on these rare imported cases. So in terms of monkeypox in the news, unsurprisingly, the 2003 incident in the US generated a large number of headlines. And indeed, this even made the news over here in the UK. Here's The Guardian from 2003 asking, should we be worried about monkeypox? And the answer is there's little reason to be, which, while probably defensible back then, it hasn't aged well. The Sun got involved with the imported cases with their usual balanced views, showing how the hospital was to blame for an NHS worker who unfortunately became infected. And there were two separate cases imported in 2018. And in both of those, it took a while to diagnose monkeypox. It's such a rare, neglected tropical disease. Unfortunately, in one of these cases, a healthcare worker changing the bedding of someone before the diagnosis of monkeypox was made managed to contract the disease. Where we should have been focusing our attention was on some nice publications which were alerting us as to what might be coming ahead. Now, we'd already known that the smallpox vaccination doesn't just protect you against smallpox, it protects you against a number of other orthopox viruses. And there was data to suggest that the smallpox vaccine is about 85% effective against clinical monkeypox virus infection. So the first snap that I have up here, this is a paper from 2010. And this is warning the major increase in human monkeypox incidence 30 years after smallpox vaccination campaigns ended. And the reason why this was so important is the average age in the DRC is about 18.5 years old. So now that we have moved more than 30 years away from the end of this smallpox vaccination campaign, the overwhelming majority of the population does not have immunity against orthopox viruses. And similarly, from 2018, there was a very nice report that 39 years after the last reported case of monkeypox in Nigeria, there were 122 confirmed or probable cases in 17 states, including 7 deaths. And again, we've got the same problem here. The average age in Nigeria is about 18.5 years old. So when you've got the majority of the population that doesn't have immunity, what you're going to see is an increase in primary cases. You're also going to see an increase in secondary cases. And if these countries have good travel and business links to other countries, you're going to start seeing imported cases. And while DRC is not particularly notable for having great travel and business links, Nigeria certainly is. And so unsurprisingly, after the first cases were reported in Nigeria in 2017, we started seeing imported cases in other countries around the world. The first two were both into the UK, and both were in September 2018, just a few days apart, but they are completely unlinked cases. And as I've already mentioned, the treatment of one of these cases led to a healthcare worker also becoming infected. But in 2018, we also see an imported case into Israel. In 2019, there was a case imported into Singapore. And at the end of 2019, we had our third importation, fourth confirmed case in the UK. And then we had a 2-year hiatus, which aligns perfectly with the COVID travel restrictions. As soon as those eased, we got our fourth importation, and this was treated just over the road at Royal Liverpool. One imported case, but unfortunately 2 family members also became infected. And later on that year, the US got their first imported cases, 2 completely unlinked cases. And our story finishes in May of this year, where we had our 5th separate importation, 8th patient confirmed with monkeypox into the UK. When it comes to symptoms of monkeypox virus, it starts off as quite a generic febrile illness. You've got things such as fever, headache, myalgia, the typical symptoms you get when you have an infection. But then you get more indicative symptoms such as swollen lymph nodes. And this is quite unusual for poxvirus infections. It's quite a differential. It's not seen in particular for smallpox. But the real indicative symptom that you're seeing here is this progressive rash that can affect all parts of the body. It starts off as a flat macular rash, and then you get this raised papular rash, which will eventually progress into vesicles and pustules. These will scab over, crust over, and eventually fall off. Now, the number of pustules and scabs can vary markedly. You can get patients with single figure scabs, but you can also get some unlucky individuals which will have more than 200. So these are some photos from our friends in the HCID network. This is from one of the imported cases in 2018. And you can see these classic lesions affecting most of the body, including some that are starting to scab over. This unfortunate person had about 160 lesions across their body, just about every part of the body affected, but in particular the genitals and the buttocks. And with the current outbreak, we've moved into the era of live tweeting your monkeypox virus infection. So I'm going to show you 2 photos here. The first one's up on screen, top right at the moment. This is what I, as a non-clinical person, would see as a classic monkeypox lesion. The second photo I'm going to show you isn't. So this is the same patient. Obviously, this isn't just the monkeypox lesion that's at play here. There's quite a significant bacterial secondary infection that's resulting in this. But this is just to show that it's not just all classic lesions that appear on the body. There's some good news when it comes to treatment. We know that all 3 generations of the smallpox vaccine offer good protection against monkeypox. Indeed, all 3 are estimated to be more than 85% effective. And we also have antivirals available. Now, these are antivirals which are licensed for treatment against smallpox, but they are being utilized in this current outbreak. And one of the silver linings that we might see from this outbreak is data from tecovirimat and bridcinidavir, how effective they are against other orthopoxvirus infections. So it's important to say that when we've seen these cases of monkeypox virus in the UK, it causes some problems in terms of treatment. And that's because monkeypox is classified as a high consequence infectious disease, or HCID. Now, this is a definition of any disease which is typically acute infectious disease with a high case fatality rate and may or may not be effective prophylaxis. It's difficult to diagnose, recognize and detect rapidly. This is especially true for monkeypox virus. Almost all of the imported cases that we saw into the UK were initially diagnosed as a more common molluscum contagiosum infection, which is endemic in this country. But as we know, all of them were actually monkeypox virus. An HCID will also have the ability to spread within the community and healthcare settings, which again we've seen with monkeypox virus with the healthcare worker infected in 2018. But in summary, these are a collection of diseases that require enhanced individual population and system responses in order to deal with these cases. It is important to say here that the current outbreak clade, this with the new nomenclature, this 2B clade, has been derogated from being an HCID. This derogation came last month, but the original clades, so this is now Congo Basin and West African, so this is 1 and 2A, these are still considered to be an HCID. So HCIDs in the UK are classified as either contact or airborne. Monkeypox virus is in the airborne category. Examples of contact HCIDs include Hunin, Mashupo, CCHF, Ebola, Lassa, Lujo, Marburg, and SFTS. And then with the airborne, we've got Andes hantavirus, we've got 4 avian influenza viruses, we've got MERS, the original SARS, monkeypox, Nipah, and then our token entry from a bacterial pathogen with Yersinia pestis in the form of pneumonic plague. These are airborne HCIDs. And when we get these cases, they need to be managed in specific facilities. There are 2 HCID centres that can deal with contact HCIDs. So this is the Royal Free in London, and we've got the Royal Victoria in Newcastle. But for airborne HCIDs, we've got another 3 facilities that can be utilised. We've got Guy's and St Thomas's down in London, and then we have the Royal Hallam, and we have the Royal Liverpool that can deal with these cases. But in total, we only have capacity for about 50 or 60 cases of airborne HCID, which is always thought to be about 10 times more than would ever be utilised at any one point. But as we know from 2022, this was woefully insufficient for what was to occur. Now, some of you might have seen what the inside of an HCID room looks like. We've got the Royal Liverpool just over the way. For those that haven't, here's some photos from the Royal Free Hospital. This is where myself and Susie have spent a lot of time over the last couple of months doing some monkeypox sampling, which we'll discuss later on in this talk. But in essence, what you've got is on the left-hand side, you can see the ante-room. So that this is an area between the main corridor leading into the patient room. And you might be able to make out there's some yellow tape across the floor. This is demarcate this lobby, this ante-room. And the idea being that as you come out of the patient room, you'll doff your PPE as close as you can to the patient room. You'll get the majority of the heavily contaminated items into the local waste streams. You'll then step across into what is nominally the non-toxic area of the laboratory, where you'll have further disinfection, decontamination procedures before you'll eventually step back into the corridor. On the right-hand side, you can see a picture of the room itself. It's as basic as it comes. It's a single bed, a tiny flat screen TV, some basic IKEA wooden furniture. It's not somewhere you want to spend any amount of time, which is quite unfortunate because many of the people that have been in these isolation rooms have been in there for several weeks. But what you do have on the inside of this room is the ability to bring in specialist equipment and perform specialist techniques, which might be important because some of the people that enter these rooms might get very sick. Now, this whole facility is under a negative pressure cascade. So air is drawn in through the corridor, into the lobby, into the patient room, through into the patient bathroom, where you'll have the ventilation extract. This will be filtered before being recirculated. And the idea of this is to provide optimal protection for the people in this facility. It's drawing air away from the main corridor and out to be processed. So that's the background done. I'm going to give you a little bit of environmental sampling that we did before the start of this monkeypox virus outbreak, because we've actually done some monkeypox virus sampling before 2022. But before I move into that, it's probably worth saying a little bit more about where I work, which is the biosafety group at UKHSA Porton. So according to our webpage on the .gov.uk website, we're specialists in aerobiology, biocontainment, and biosafety. We provide expertise, advice and consultancy to government departments in the commercial sector. It lists a whole range of things that we do. Most of it's quite mundane, such as testing of laboratory and medical equipment. So if anyone's ever ordered a centrifuge with a biocontainment rotor or bucket, that has been tested in the biosafety group to show that it's fit for purpose. We've got a whole list of other day-to-day activities: gaseous disinfection, biocontainment, aerobiology, water microbiology, disinfection. And then down at the bottom, as almost a throwaway, is bioresponse activities. Now, these are typically quite rare, but when they happen, they tend to be quite special. So this is the biggest response we've done. This was to a fatal case of anthrax in 2006, the first fatal human case of anthrax in the UK for nearly 30 years. And this involved a very large team of people from Porton being sent up in Martindale suits to go and sample numerous premises on the England-Scotland border in these rural locations. And this was all due to illegally imported animal hides from Africa, which unfortunately were contaminated with anthrax spores. And these were then made into djembe drums, and these went into local community drumming circles. And unfortunately, one person died of anthrax. And in the middle, you have me and my now boss 15 years ago, with me giving a lovely demonstration of how you surface sample an old vacuum cleaner using a blue sponge. This was supposed to be a once in a generation event, but 2 years later, we were back doing the same thing again. This time we were in central London, so not only did we have all 3 emergency services and Gold Command and a hazardous area response team, we also had the local media who started off by camping out on the top deck of double-decker buses, going around trying to film us. And eventually we just said, look, come back after we've got the samples out and we'll give you the media opportunity so you can report on what's going on. Unsurprisingly, with the COVID outbreak, we were asked to provide assistance from the early days. So this is Arrow Park, which is somewhere that some of you might be familiar with. This is just down the road. You may know that Arrow Park was the isolation centre that was set up for the first potential cases of COVID in the UK. So these were people on the Diamond Princess cruise liner, which suffered a very large outbreak really early on in the pandemic. These were repatriated back into the UK. They were put up at Arrow Park, and we were asked to go around and see if we could find any SARS coronavirus 2 on the surfaces in this isolation centre. More recently, we've been involved in the avian influenza, the first human avian influenza case in the UK. But the majority of our stuff that we do is actually healthcare associated infections. So there's been numerous HCAI responses, including Staph capitis, Legionella, Pseudomonas, Mycobacterium, carbapenemase producing Enterobacteriaceae. And we did a huge amount of work for the swine flu outbreak in 2009. And in fact, down at our Porton site, we've got an environmental chamber to demonstrate the effect that aerosol generating procedures have. And we've also just built a new mock hospital ward, which will allow us to do a lot of the experiments in more detail. While this might sound quite fun and glamorous, it's not always the case. Back in 2010, you might remember that there was another anthrax incident, and this was contaminated heroin. So what they believe happened is someone smuggling heroin out of Afghanistan had used an animal hide to smuggle huge amounts of heroin out. And they do this because animal hides overwhelm sniffer dogs' receptors, so they can't smell the drugs that are in there. Unfortunately, one of the animal hides was probably contaminated with anthrax spores. This ended up killing quite a lot of people all over Europe. Unfortunately, when one of these patients is being managed in the UK, someone put clinical anthrax waste into the wrong bin, and we ended up having to remediate 7 lorries. This is only a half full lorry. We had 7 floor-to-ceiling full lorries full of these clinical waste sacks. We had to repackage, incinerate them all, swab the lorries, decontaminate them, swab them again. This took the best part of 3 weeks to complete this, and it's as fun as it looks. So when it comes to sampling, we've got a number of sampling techniques. At the moment, we're usually using the Copan swabs and UTM. So if you ever had a COVID test, someone stuck a swab up your nose, back into a tube. This is exactly the same thing that we use to do our environmental sampling. We also use blue Enviro sticks. And this is something that's been designed by the food manufacturing industry. It's actually a safer way of taking a swab. It can be actually placed onto food items without leaving any toxic chemicals. We also do a whole range of air sampling. I won't bore you with this at the moment. Safe to say that there's a number of very intricate, very clever devices that allow us to get some exciting data on the types of air contamination that we're seeing in these different environments. And then in our basement, we've got a whole range of air and surface sampling equipment that can be utilised for specific investigations. So onto the investigations themselves. 2019 was the first time we performed environmental sampling for monkeypox virus. So this was a case that came back to the UK when they were fully infectious, a large number of pustules all over their body. They took a 4-hour bus trip down to their residence and then spent 2 days in adjacent properties. It's their flat and their brother's flat, which were co-located on the same floor. Because this was a council property, we were asked to go in, see what contamination was there, got in some professional decontamination experts in, and to see what was there afterwards. We were also asked to sample the bus. Now, we didn't find any positives on the bus, but that had been cleaned numerous times before we got down there. But we did see a large amount of contamination over both these properties, even though the patient was only in there for 2 days. Now, you're going to see a lot of very complicated tables in the remaining slides. Don't have to worry about them. I'm just going to point out the highlights from this. So we took 45 samples in total. There were only 3 that didn't contain any monkeypox DNA. There are another 2 that are invalid, but everything else we saw evidence of monkeypox virus DNA. These are ordered by CT values, so the lower the number, the more contamination is present. And we saw a large number which had what we consider to be significant contamination. So we did viral isolation on a number of these, not just on the 10 most positive. We did that on 10 samples. It gave us a good indication of what was going on across these two residences in key locations. And we were able to isolate virus from 6 of these, which showed us that the contamination that was present had the potential to cause onward transmission, to cause other infections. We were also able to get electron microscopy and whole genome sequence data. If you want to know more about this, this is published in Environmental Microbiology. In 2021, we were also asked to assist with the imported case that was treated in the Royal Liverpool Hospital. So this is all with a collaboration with Tom Fletcher and Susie Gould here at LSTM. They were involved in the patient care, and Susie went in and took a load of swabs both during and after the patients were in these isolation wards, and even after they've been decontaminated. And again, there's a lot of data up on this slide. The summary information is that we were able to see monkeypox contamination in all of the patient rooms. There was less seen in case 3, room C, but this is because this was a very young child that wasn't as mobile as with the other 2 cases. We also saw it in the step-down rooms. So these are our isolation facilities, which were not being used for that purpose. This family had other small children that needed to be cared for, and so the parents who weren't infected would be in that environment. And this included after they had been discharged from their isolation wards. They clinically resolved the symptoms of disease. So there are a number of interesting things that we saw here. Most notably that we had 3 positives after decontamination being completed. That's not a huge surprise. Decontamination is only supposed to remove the presence of infectious pathogens. So the fact that we can still see genome there is not a huge problem. The question is it still infectious? And we did viral isolation on the 2 most positive samples from all 5 of these rooms, plus the 3 post-decon positives. Now, the good news is that nothing from the post-decon that showed DNA contamination had infectious virus, but we did get 2 samples that we isolated infectious virus from, including quite a strong positive from case 2 in room B, but we also found one from one of the step-down rooms. So there's going to be a little bit more investigation into what's going on here, but Susie is busy writing this manuscript at the moment, so hopefully it will be out in a month or 2's time. So this now brings us up to 2022, where we saw our paradigm shift of monkeypox virus. Now, the story actually started exactly how it had done previously. It's the 7th of May 2022, and we had an imported case from Nigeria, 116 contacts all followed up, none developed monkeypox. This is exactly what we'd seen before, exactly what we were expecting to see again. That wasn't quite the case, and this would eventually become known as cluster 1. Now, it is important to say that cluster 1 is exactly what it appears. It is an important case. It has nothing to do with what follows. But unfortunately, there were positives that followed quickly after. And so until we were able to resolve this, we weren't excluding the fact that these were related. And it was quite quickly afterwards. It was the 12th of May where we had a family cluster identified, 2 confirmed positives and 1 suspected. The suspected case had had the same symptoms about 2 or 3 weeks previously, but they had resolved their infection. What was different to what we'd seen before is that there was no travel to endemic regions associated with any of these patients. There was no source of infection identified. Now, the good news is none of the 98 contacts, including healthcare workers that were followed up, developed monkeypox. But this was a big problem of where these 2, probably 3 people got this infection. So this would eventually be called cluster 2. And the story started to resolve on the 16th of May. Now, as part of the wide net that was spread to try and find out what was happening with this cluster 2, 4 new cases were identified. Now, all of these were adult males, no travel to endemic countries, no links with clusters 1 or 2. But all 4 of these were in the gay, bisexual and men who have sex in men community. And the reason that these were investigated is that as the contact tracers were going around, people trying to find out what was going on, it was reported that similar symptoms were being seen in some of these sexual health clinics, and maybe that there was something that was going on that was unnoticed. And 4 samples were set down as examples of this, and all 4 of them were positive. Now, 2 of these cases do have an epidemiological link, but the other 2 have no connection with the other 4 cases or with clusters 1 or 2. And so this became known as cluster 3, and this is where the incident really stepped up. This was a change in the type of outbreak that we saw with monkeypox virus. So previously, we'd only ever seen level 1 outbreaks. So this is just a standard importation. And if any transmission occurs, it's normally quite obvious. It's this close contacts, it's family members, it's predictable secondary transmission. What we were seeing back then and what we're still seeing today is a level 2 transmission event, a level 2 outbreak. So this is transmission within a defined subpopulation with a high number of close contacts. Now, the worry when we first identified cluster 3, and the worry we still have today, is that we might eventually start seeing a level 3 outbreak. So this is transmission within multiple subpopulations or a larger subpopulation. So what we'd be seeing here is a large number of cases in people who aren't in the GB-MSM community or who have quite overt close contact with known positives. Now, the clinical diagnosis and treatment, especially early on in this outbreak, was a problem. Now, with the diagnosis, it's quite straightforward. We rely on laboratory confirmation by PCR. The problem was that there was only 1 laboratory in the country that's accredited for monkeypox virus diagnosis. That's the Rare and Imported Pathogens Laboratory down at UKHSA Porton. We're lucky that recently we've had a number of other NHS labs which are now accredited to perform the monkeypox virus test. But for a long time, it was just 1 lab, and that created a huge amount of problem in terms of processing all these samples. We do have definitions for probable and possible, but these eventually require PCR confirmation. In terms of the treatment, this was a really big problem. As we've already discussed, monkeypox is an HCID, and confirmed cases should be going to HCID treatment centres. But this was so big we couldn't house all of the affected people in these facilities. So they came up with a system of prioritising the most severe illness, or those who are at risk of severe illness due to other complications. Those would be managed within the HCID treatment centres. People who could safely isolate at home with non-serious illness, they would do so. And people who didn't have the serious illness but didn't have a way of safely self-isolating at home, these would be managed in infectious disease centres around the country, which have an elevated system of infection prevention and control measures, but not quite at the level of the HCID network. Now, there was no other choice here. There were hundreds of cases and only a small number of beds in the HCID centres. We couldn't do anything else, but it did present some residual risks. Monkeypox virus is a category A virus. You have to deal with the waste in a specific manner. This is easy to do in the HCID centres, it's easy to do in the ID centres, but for people at home, their waste is going to get picked up by the bin collectors and it's going to end up in landfill. So this raises the possibility of potential spillback, infecting natural UK rodents or squirrel populations that might be a reservoir for the virus. So I'm not going to spend a huge amount of time on the situation at the moment, but there is a large amount of transmission within the UK. If you are interested in this, go and have a look at the monkeypox technical briefings. They are actually really interesting documents. We've just had a technical briefing 5 published. This is up to and including the 12th of August. In there, they confirmed 2,638 cases in England, a few hundred more in Scotland, Wales and Northern Ireland. About 3/4 of the cases are in London. 95% of them are in the GBMSM community. Interestingly, 30%, about a third, report having 10 or more sexual partners within the last 3 months. And this, to me, highlights what is going on here. This is, you see in the media people saying that this is a disease of homosexual people, which is not true. This is a virus exploiting specific human behavior. And people who have prolonged close contact with multiple people are most at risk of firstly acquiring and then transmitting monkeypox virus. It is quite confined within the GBMSM community at the moment, but we have seen 22 female cases and 1 case in a child. Here's the latest epi curve. We need to be a little careful here because it takes about 3 weeks to confirm cases. And that's because while we like to think they're reported nice and quickly, it's not always the case. It sometimes takes a few weeks to firm up data for any specific day. So it does appear that we are decreasing in the number of new cases reported. Hopefully that is proven to be true when we get a little bit further out. And this, if it's occurring, is almost certainly due to the excellent messaging that is being provided within these sexual health networks, and also because of the vaccination that's being undertaken. Now, they stopped reporting this table of events that can lead to transmission. The last one was in technical briefing 4, but I think this is quite interesting data because what they found was that sex on premise venues, which there's not many of these in the UK, there are a few in London and a couple elsewhere around the country. There's a high association with attendance at these venues, and indeed with festivals which have a sex on premise component to them. These are highly indicative for the people that eventually end up contracting monkeypox virus. It's almost certainly that these were significant spreading events. So what sampling have we done in 2022? Well, there were a number of public health research questions that were raised. We need to assess the suitability of IPC, this is infection prevention and control measures, and the PPE that's used in these isolation wards. Are they suitable to protect healthcare workers? Are they suitable to contain the pathogen? We needed to gain information on the level of contamination in risk environments, patient rooms, these lobbies or ante-rooms, the general wards, and if there are any affected domestic or workplace environments, what's the level of contamination in these different environments? And we also needed to assess the transmission risk activities. We saw in 2018 that changing the bed linen of a patient led to a healthcare worker being infected. But there are other activities that might be high risk as well, such as doffing of PPE. So here's a photo of me and Susie down in the Royal Free Hospital on what was the first heat wave that we saw in the UK back in late May, early June. Not a great day to be in what felt like 700 layers of PPE, but this is the type of PPE that's worn in these facilities. We've got the typical hospital scrubs, we've got a disposable gown, we've got a FFP3 mask, visor, double gloves, and you sweat a lot when you're in this PPE. Just with a few minutes worth of work, it's not very breathable material. The Royal Free Hospital, you don't want to end up there. The one consolation is you get some dramatic views across London, Still not enough to make me want to spend any more time down there. But we did get some good sampling done. So what we found is when we went around these patient rooms, we found significant surface monkeypox contamination. In fact, every surface sample we took in the patient room was positive to some degree for monkeypox contamination on the first couple of trips down there. We did eventually get some negative ones, but the majority had huge amounts of monkeypox virus DNA present. We also saw positive air samples, in particular positive during a bed linen change, which is important because of what happened in the 2018 case. We also sampled PPE. This was unsurprisingly highly contaminated, as was the floor area, which was the area above which the PPE was being doffed. And we were able to isolate monkeypox virus both from surface and air samples, including during the bed change. So we are able to actually isolate virus from that particular air sample. Don't worry about this table, we're not going through all this data. This is just to highlight that we've done lots of individual patient rooms, sampled lots of individual patient rooms. We're seeing similar trends between them, but there are some interesting differences. So the box that I've highlighted on the left, the red box on the left, this is someone that is 9 days post-onset of symptoms. The right-hand side box is someone that's 6 days post-onset of symptoms. But the level of contamination we saw in these two environments was very different. In fact, it's about 1 to 2 logs difference between them. So while these areas are still contaminated, it's not a ubiquitous level between them. We also were able to find very trace amounts of monkeypox DNA in the corridors. And we're coming to the end of an experiment which will show what is happening here. But the theory at the moment is that the healthcare workers are wearing clogs in these environments. Now, these are obviously going to be highly contaminated from walking around the patient areas. These are removed very quickly in the lobbies as these are put into a waste stream. You then move into clean clogs as you exit out. But the problem with autoclaving is while this will completely inactivate any virus that's present, it doesn't get rid of the genetic material. It does break it down, but there's still fragments which can be amplified by PCR. So what we think is happening here is that these clogs are getting recycled, and while there's no monkeypox virus that can infect someone on them, there is still DNA which people then traipse around, which is why we're seeing these low levels in areas which shouldn't have any monkeypox virus present. We've also done an office investigation. So this is an individual who contracted monkeypox. They attended their place of work on the first day of illness. This is the prodromal phase. They just had non-specific symptoms. They had malaise and a headache. They were in this environment for a day, after which they started developing more significant symptoms, isolated at home, eventually tested positive. We were able to go in and sample the entire environment. We found 3 positives, all at the desk of this affected individual. And there were a number of other samples taken from that desk which were negative. But critically, these were all very low levels of DNA that were detected, all just above the limit of detection. But it does go to show that you do get contamination occurring in workplaces if people are attending them very early on in their illness. This is on medRxiv if anyone wants to read a bit more about this. In fact, just yesterday it was accepted for publication in the Journal of Hospital Infection. We're also doing work in sexual health clinics. So excuse my crude drawing here, but this is the biggest sexual health clinic in the UK. And the majority of positive patients, this is their first interaction with a healthcare professional. It's at a sexual health clinic. These are people that use this facility rather than your general practitioner, the GPs and other healthcare systems. This is usually their first interaction with the healthcare system. So we've got this sexual health clinic is going to be taking weekly samples from the 7 locations that are marked on this photo. So these are the areas that the patient will usually be in, as well as 2 for where the healthcare worker will be seated. There's an 8th sample, which isn't shown here. This is the door handle on the way out. We've already analysed the first set and found no positives from there. The second set, the PCR data is off tomorrow, and then we're going to run this for 2 further weeks. But it'd be very interesting to see if this trend continues of no monkeypox virus contamination in these sexual health clinics, although admittedly this is a small sample size. To summarise the environmental sampling findings to date, we've seen significant contamination in patient rooms and healthcare worker PPE. Contamination levels do vary though from patient to patient. We've seen air sample positives from a bed linen change. We know that DNA does not equate to viable virus, but we have isolated virus from both surface and air samples. We've seen contamination in an office workplace, but fortunately this was low level contamination, excuse me. And I think our most important finding, which is a lot of the driver behind what we've done, is to see whether the current infection prevention and control measures and PPE guidance was sufficient. And I think our data has shown that this was the case. There were some minor modifications introduced to strengthen these, but on the whole, they were fit for purpose. So I'm going to leave you now with the words of John Cohen from his article in Science at the start of this outbreak. Another neglected tropical disease of the poor gets attention only after it starts to infect people in wealthy countries. And there's a quote, "It's as if your neighbour's house is burning and you just close your window and say it's fine. Now the fire is spreading." And I think this is a perfect summation of what's happening, not just with monkeypox, but a number of other important neglected tropical diseases. We know that these might become problems. We only seem to care about them when they start infecting people a little closer to home. So with that, I'll leave you with this acknowledgement slides, and I'm happy to answer any questions that you might have.
Thanks, Barry. Hey, Joe. Do we have any questions in the room first before we? I'm going to do the mic. Sorry, that's really annoying.
Thank you. Thanks for your talk. So you mentioned at the beginning that the, let's say, theoretical mortality rate is about 10%, right? But this is not the case in, at least in the UK cases. Is this because the virus has changed, or because everyone that's positive is just treated and then everything's fine?
I don't think we can answer that question entirely at the moment. Both of those may contribute. We don't know whether the genetic changes that we have seen have any difference in the phenotype. But what we have seen with other infectious diseases, such as Ebola, which has a very high case fatality rate out in endemic regions in Africa. But when you get cases that are treated in what we consider to be Western hospitals, I don't think we've seen a single Ebola fatality with a couple of dozen people treated in European and American hospitals. So we're not quite sure of what the contribution of the genetics, what the contribution is of potentially better healthcare systems. My guess is that there's probably a contribution from both here, but it may just be one or the other.
Thank you.
Mine's kind of a double whammy question. So are there any cases in the UK in the current clade that people do attribute to airborne infection?
What I will say is there are cases in the UK at the moment where just a very small number, which is difficult to ascertain how that infection occurred. But it is an extremely small number. I don't think we can say that they're airborne. It could be fomite, it could be other things that are going on here. But it's unlikely, with all the cases we've seen, if airborne transmission was likely, the epidemiology of this outbreak would look very different in terms of who is becoming infected.
And that sort of ties into, I've seen in the media that people think perhaps this clade, the distribution of sort of sores is more localized, particularly to sort of mouth genitals and less so distributed around the body. Is that true?
We're learning as we go through this pandemic more and more about the clinical presentation and how that might be attributed to initial infection. This is probably a question that's better for Susie than me. I don't know if Susie actually wants to contribute to this, but there is a belief that because infection will frequently occur through an abrasion maybe even a microabrasion on the skin. That could be the initial start. What happens after that, we're less clear on. We don't believe that it becomes a systemic infection, but how it then progresses to other areas of the body, you'll get a lot of debate on that. But certainly, there are a lot of people who say that what you're proposing is true, that you'll see the first symptoms developing in the genital regions if it's a sexual transmission with not STI, but through direct contact, through sex, that you will see a presentation in that area more. But again, this is stuff we're learning as we go along. I think in the next few months, you'll start seeing more and more data and more evidence to show that this is probably happening. Do you want to jump in with any more than that, Susie?
I think it's like the virus probably has some capabilities, but I think you're right.
Sorry, Susie.
I think the site where you're first exposed to the virus. With the
Thank you.
Can I jump in? I guess a lot of the data that you've shown is PCR positivity from environmental sites, and you've shown CT values and so on. But as you said, we don't necessarily know that detection of the genetic material translates into infectious virus. Is anything known about, is there any threshold for saying at this CT value, this is, you're going to isolate the virus and below is less likely, or do we not know that level of detail?
So yeah, the short answer to that is we don't know that level of detail. In the manuscript or the paper that's now published in Environmental Microbiology, we proposed that CT30 might be indicative, at least for prioritizing, because we're suffering from this at the moment. This is a complex process to perform these viral isolations. It's a 2-week process with multiple PCR time points. So we suggested CT30 for prioritizing, but the air sample that we had positive, which we prioritized for isolation because it's so important, that was CT32.4. But you might have also noticed from the 2021 data, we had positives that were in the high 20s, which didn't result in viral isolation. So I still stand by what we wrote, that CT30 is good if you can't perform isolation, other than that's a good kickoff point, but you'll have lower values than that, or higher values, so less contamination, which will result in isolation. You'll also have ones which are more contaminated, but you won't. It's just like what we see in SARS. We see patients with CT value in the high teens that we can't isolate virus from for some reason, but it'd be lovely if it was a direct relationship.
In terms of the maps you showed in the early part of the presentation, I think it's from 70s, 80s, 90s, how representative of what was actually going on at the time do you think that was? Do you think a lot of cases were missed?
Yeah, I mean, almost certainly there were cases missed. I think the broader trend is probably accurate. We believe that the smallpox vaccine was very protective against monkeypox. So it's certainly in the 80s, we wouldn't be expecting to see very many cases because that eradication campaign was so successful. I believe that the trend is accurate, but you're right, the data themselves are likely underestimates of what's happening.
Great, and we've got a few questions online, so I'll just read them out. So Emily Adams says, super interesting talk, thanks so much. A couple of questions. What is the situation in Nigeria now? Is there an increase this year? What other fires are burning, which I know you've got a whole presentation on, so we'll maybe say there'll be another seminar hopefully coming soon on that one. And more of a technical question, do you know what the average and range of the CT-PCRs are yet?
Wow. Okay. So
A lot to unpack.
Yeah.
I can put it up here. So I suppose the first question then is, what is going on in Nigeria, and are they seeing an increase?
So there are cases in Nigeria. They are seeing an increase, but nothing in the way that we're seeing here in Europe and America and many other countries. They still, let me phrase this so it doesn't sound like I'm accusing them of anything. They do not believe that sexual transmission or transmission through close contact, predominantly through sex, is a major driver for them. They say that they're not seeing the same number of cases in the GBM MSM community. You have to remember that there's different opinion of that community out in Nigeria, so it's probably difficult to untangle that. But yes, cases are increasing, but not the level we're seeing.
And then what other fires are burning?
Yeah, there are other fires burning. You're right, I do have a talk on this, what is going to be the next virus to make the jump. So if anyone is interested in this, the best place to go and look is the WHO R&D blueprint prioritises where they think money should be spent in terms of research and development. That is a great list of pathogens. What my talk is on is the pathogens that are not on there, that should be completely neglected. Monkeypox was originally on that talk. I can't use that anymore. Certainly things like enterovirus D68, which has caused some big problems on a biannual basis in the US, and we started seeing our first cases in the UK in 2014. That was shut down in both countries because of COVID, and now we're starting entering the period where this might come back. So that's an example of something. Obviously, we've got polio, which wasn't on my list. I thought that was going to be eradicated within 5-10 years, but no, we're starting to see cases again. That's something that probably needs a bit more attention, especially of which type of vaccine we're going to use going forwards if we're seeing this virus in our sewers and sewage wastewater and elsewhere. But there are a number of viruses that people need to be concerned about. Certainly if you look into Asia, something like severe fever thrombocytopenia syndrome, which is now called Dabby Mountain virus, I believe. That's something which is overlooked, but it's a whole talk on this.
And then last one is, do you know the average and range of the CT-PCR values that you're seeing? I assume that's in clinical samples.
In clinical samples, it's highly dependent on obviously the stage in their disease when the sample is taken, also the sample site as well. So lesions are usually hugely positive. Whereas if you take a nasopharyngeal swab, for instance, that can be a little less indicative of the overall situation. But swabs is what we normally go for. We've also received urine and feces and blood, serum, everything, but it's swabs you're looking for, and it's usually very positive. Those scabs, those lesions, that's virus and or your immune cells responding to it. It's a highly concentrated package of viral material. So, and this is something to be wary of, because we saw with smallpox that people could isolate smallpox virus from a scab that had been left at room temperature for more than a decade, still contained infectious smallpox virus. So it's important to remember with these scabs, that is probably very infectious material that's in them. We need to be a little careful with those.
Great. Yeah, Tom Edwards.
Cheers, Barry. Great talk. Probably a difficult question, but say if we could go back in time 10 years and we'd pay attention to the data coming out of DRC and Nigeria, what do you think we could have done to stop this happening, or to at least have been better prepared?
Well, I think the low-hanging fruit there is the smallpox eradication campaign could have been restarted in endemic countries. It's probably not a bad thing to do anyway. We've seen with polio virus that people were missed with polio virus as part of that eradication program. It was probably missed with smallpox as well. That almost certainly in endemic countries would have topped up their orthopox virus protection. That would have stopped a lot of the primary cases. Whether that would have prevented this situation from happening, maybe, maybe not. You'd probably have to get the cases down to zero in terms of monkeypox before you can eliminate the potential of what happened. But that would be the low-hanging fruit for me. I don't think that this is something that we should be excluding now. We've got a very effective monkeypox vaccine, which is actually originally a smallpox vaccine. So we could be restarting, especially in the endemic areas.
Great, I'm going to carry on online unless anyone wants to interject. So we've got a question from Jeff, which is, RE the hospital sampling, is there any air sampling done on ventilation between the different floors of hospitals to rule out similar events to the Mesgate outbreak of smallpox in 1971?
Yes, that was a very interesting case. The answer to that is no, we haven't. We have swabbed the ventilation system. We have not done air sampling in there. It's going to be quite difficult to get to the correct part of the ventilation system to do that, but it's a very good point and it's something that's definitely worth considering.
Great. And then from Salwa, is there any specific guidance, because we saw a lot on Twitter that you should throw bleach down your toilet for environmental waste, is there any specific guidance for decontaminating waste for home isolated patients in order to reduce environmental risk?
I hope there is. My fear is there's not. I was keeping close track of this in the early days. And we do have specific cells set up in UKHSA to try and manage this. There is recommended guidance. I don't believe it's as strong as it should be. But the problem is that a lot of household bleaches that people get told that is effective, but it's only if it's used correctly, which many people don't do. So.
Yeah. And then last question online, and we'll probably let people go unless there's any more, is just a comment. There was just an outbreak of 41 cases in a prison in northern Nigeria, and they most likely person-to-person transmission.
Right.
So that's just interesting to note. And yeah, that's all. Oh, and it's been submitted for publication, and that's from Luis Cuevas, one of our professors. So he'll share that with you.
Excellent.
So that's very
Yeah.
cool.
Very interesting.
Luis. Do we have any more from in here? No? Well, thank you so much again, Barry. Fantastic talk.
Brilliant, thank you.